Let's consider the quadratic inequality 3x squared is greater than 1 minus 2x. In this inequality, you want to first set it to 0, so we want to take these two terms to the other side. That will leave us with 3x squared plus 2x minus 1 larger than 0. Fortunately, in this problem, we have a factorable trinomial, so let's factor it. 3x and x with 1 and 1. If we want this to be positive 3x minus 1x, we'll get what we want. And so now we've got the factored form of the trinomial on the left greater than 0. Now that will give us two key points. One key point, the easier one, is negative 1. The other key point is positive 1/3. In this case, neither key point can be part of the solution because we have greater than. If we had greater than or equal to, we could use these points as part of our solution. We now have 3 intervals to test. We need to choose a sample number in each interval, substitute into our left side of our inequality, and see whether we get true statements or false. Let's see what happens. Let's try x equals negative 2. That would give us negative 6 minus 1 is negative 7, and negative 2 plus 1 is negative 1. And we want that to be larger than 0. And it turns out that negative 7 times negative 1 is positive. So yes, that will be true. That means anything to the left is true. So we can write that right now as part of our solution. And we can graph it like so. Let's test a number in the middle. We'll have between negative 1 and 1/3, we could test 0. That's always the easiest one to check. So then that would give us negative 1 times positive 1. Is that larger than 0? Well, no, that's negative. So this is not part of our solution. There are no solutions in that interval. Let's test on the other side. We could test x equals 1. If x equals 1, then we have 3 minus 1 is 2, and 1 plus 1 is 2. Is that larger than 0? 2 times 2 is 4. 4 is larger than 0. So yes, this interval checks. Any number in this interval will make the inequality true. So we have the rest of our solution is this. So we have open holes here, and we have anything below that and anything above here. If we write that algebraically, we'll have x must be less than negative 1, or x is greater than 1/3.